Hi, this is Chris again. I'm here to talk about Unit 64, Problem 29, from Mathematics for Machine Technology by Smith and Peterson. I'm an instructor at Shoreline Community College. Looking at the problem, there's no obvious place to find measurements for determining angle x, so we'll use some geometric principles and construct some lines perpendicular to the two sides of angle x that we can measure. The first line we'll construct is a line parallel to the smaller of the two big circles, starting from the center of the circle and going toward the biggest circle. Since that line's parallel, we know that the difference between the lengths of the two lines from the centers of the two circles is just the difference in the two radii. Next, we'll draw a horizontal line from that same circle to the extension line that forms angle x. Since those two lines that we've formed in red are perpendicular to angle x, they form angle x. Unfortunately, we still need some more lines in order to actually calculate angle x, because those two lines don't meet on things that are connected. So we'll construct a small triangle up at the top, and then a larger triangle at the bottom. And if we add the angles of those two triangles at the corner next to x, they'll actually form angle x. So let's get going. So what information do we have about our two triangles? Our smaller triangle, we know the adjacent, and we actually know the opposite. It's the difference between the largest and the next largest radii. So the largest radii is the diameter divided by 2, or 375 thousandths. The next smaller diameter is 620 thousandths. Divide that by 2, and its radius is 310 thousandths. Take the difference, which is our opposite, 375 minus 310, gives us the distance 65 thousandths for the opposite side. The adjacent side is, of course, the distance between the centers of the two circles, 1 and 330 thousandths. Now we'll use Pythagorean theorem to calculate the hypotenuse of this triangle, which we'll use then to calculate the other angle. So we know that a squared, the adjacent squared, plus b squared, the opposite squared, equals c squared. Putting in our values, we have 65 thousandths squared plus 1 and 330 thousandths squared is equal to the hypotenuse squared. When we convert those, we have 0.004225 plus 1.7689. That gives us 1.773125. Take the square root of both sides, and we find that the hypotenuse is 1.33158739. That's one of the sides of the other triangle. Now I think we've got enough information to solve our problem. So let's calculate angle A. Since we have the adjacent and the opposite, we'll use the tangent function. The tangent says that the opposite divided by the adjacent is equal to the tangent, in this case, of angle A. So 0.65 divided by 1.330 gives us 0.04887218. And looking up the tangent of that gives us an angle of angle A of 2.79794347 degrees. That's angle A. Now to solve for the larger triangle, we need to figure out the side next to that 1 inch mark. Notice that 1 inch, if we subtract the 400 thousandths from it, will give us that opposite side. So 1 minus 400 thousandths is 600 thousandths. So we have the opposite, and we calculated the hypotenuse previously, so we'll be able to use the sine function to figure out the angle. So our sine says the opposite over the hypotenuse is equal to the sine, in this case, of angle B. 600 thousandths divided by 1 and 331 and a half thousandths plus. Do that and we get 0.45059 is our sine. Look that up on the table and B is equal to 26.78154567 degrees. Now we have enough information to finally solve angle x by adding A and B together, because x equals A plus B. Add the two angles together and we get 29.57948915 degrees. Rounding that to two decimal places, we get 29.58 degrees. And that's the answer to our problem in this case. I hope this video was helpful to you. Bye.